Okay, one last video for me before I get the fuck out of here, get home and hit the hay. So we're gonna go over a MacBook Air that, after liquid damage, had nothing, no CPU. So it was starting up. There was no video on the screen, no chime, no anything like that. Now this started off kind of funny because in the ticket it said no liquid damage, and we have a little bit of an inside joke going on here at the repair shop. There's one technician that always says clean as baby's bottom. The board is clean as baby's bottom, there, which means that there's nothing on it. And as of recently, that has been code for there is an insane amount of liquid damage on the bottom of the board that I did not see or put in the ticket. And honestly, this is truly my fault. Like, as a business owner, I have to. I really cannot blame this technician for that happening. I blame myself because I give one person the work that I should be giving to three people. One of the things I say we excel at here is doing a high volume of work with a couple of people. So my business model, I would prefer to pay intelligent people to work their ass off than pay a lower salary to more people to do a more average volume of work. I'd rather pay a lot of money to smart people to work their ass off, and on occasion I am a bad business owner. On occasion, I do ask too much of people, and because they are good people, because they are kind, hardworking people, they don't tell me when they should. I cannot do 30 tickets inside of a couple of hours. I can't. Honestly, I've been doing the same thing lately too, which has been driving the salesman here absolutely out of his goddamn mind because he'll tell them, what's going on, and then they'll look, and then I'll say, was clean, and then he'll look at the board and there'll be something like this on it. So yeah, that picture, that is a spill. That is a spill that was missed. But anyway, it didn't really matter because we told the person you have a bad motherboard. So we actually gave them the right service, but for the wrong reason. So here's what I wound up doing to this board. I'm going to explain a little bit of why, how I troubleshooted it, how we get to the process. Let me just zoom in on that on the table over here so you can see what it looks like. Alrighty, I actually just got the microscope camera turned off and I don't feel like turning it back on. But luckily this thing has a really cool zoom. Really cool zoom. Which it should for how much money this damn thing camcorder retails for. You see what it does there? Like how it takes everything else and puts it out of focus? Like, that's cool. I know there's a term for it that I'm missing because I'm not a filmographer or video kind of person. But yeah, look at that. Oh, that is. I'm going to wind up making that with a smaller jumper wire, maybe. But yeah. So let me show you what that's all about there. So that component that you saw that was burned was a capacitor. So that capacitor was going between 5 volts, so PP5 VSO, and ground. Now, the trace also leading up to that capacitor that was supplying it with the 5 volts before it hit this chip was also destroyed, so this chip wasn't getting the 5 volts that it was supposed to be getting. So let me show you a little bit about what I'm talking about here. So when you look on the schematic, that capacitor is right by a chip called U7400. What U7400 does is it controls the power that is going to the CPU. Alrighty, so let's just get a look at this chip. Again, sorry that the display, it does look like shit because that's 1080p instead of 4K, because my cat destroyed the cable that allows me to get 4K to this TV. So if you're one of those people who thinks that all HDMI and DisplayPort cables are made equal and it's all the same shit, again, you may want to save the money the same way I did, but you plug the cable into the TV and instead of showing you a 4K picture, it now shows you not support. And since this is a Seiki TV, since this is a Seiki and not a Sony or a Panasonic or an LG, it doesn't say not supported, it just says no support, or no supported, or some stupid shit like that. Anyway, so let's get a better look at this chip over here and show you what I got going on. So this chip over here does a couple of things. So the whole idea behind this chip is that this chip controls 2 transistors that create power for the CPU. So on this page over here, let's see. So here's how this whole system works. Let me give you an idea. And I forget the guy's name, but I got to thank him because I was actually being a real moron in another video and explaining this totally wrong, and he corrected me. If his name comes to mind, I'll mention it in the comments. So as I said, a transistor is pretty much a variable resistor. It's a resistor whose value changes based on an input signal. So when you see this thing, I don't want you to get scared and think, oh my god, what the fuck is that? Just, again, from drain to source, or D to S, or in the case of a different type of transistor, you're going to see something called a collector and an emitter, or C&E. That's pretty much the resistor. So between here and here is the resistor. So, you know, again, what's going to drain is over here, so this is one end of the resistor. What's going to source is over here, so that's the other end of the resistor. This resistor is either totally open or totally closed based on the signal that it gets from gate. So that gate signal is coming from U7400, which I showed you on the prior page over here. So this chip. So the whole idea behind this circuit is that it creates these little pulses. And these little pulses are what tell this to actually turn on and create power for the CPU. So this is the, I believe, I honestly don't even remember off the top of my head if this is the 5-volt rail or the 8-volt rail. And honestly, I truly don't care. The whole point of this is that this is power that's going to this transistor. Now this over here is another transistor that's going to ground. So when this opens and that opens, it creates a short to ground that lets the power open through here. And then it gets sucked through here to the CPU through this inductor. So what you're doing is you're creating a bunch of little pulses that then get turned into smooth voltage by this inductor over here that you can then actually use. So let me see if I have the time and if I have the view over here of the board open so that I can show you what this looks like on the oscilloscope, because that would be really cool if I can show you on the oscilloscope what this actually looks like. I find that the oscilloscope is an amazing tool for learning because you actually get to see what the electricity looks like, and this is far more important than just hearing about it and hearing theory and reading about PN junctions and all that other bullshit. And if you look at something, it explains it 10 times. Like when you look at, again, I love Wikipedia. Wikipedia is one of my favorite websites to read. But when it comes to electronics, I read this shit and it's like, could you have come up with a more confusing and generalized explanation for it? It legitimately drives me nuts and pisses me off. And that with encyclopedias in general, to be honest with you. Alright, so there are no obvious probe points on the board for this stuff. So yeah, some of the things that I actually want to show you, here we go. CPU IMVP phase. So that is... Okay, so here we go. There's actually a probe point on the board where I may be able to show you what these pulses look like. So I'm going to open probe 225. Hopefully the probe point is not somewhere where it's hard to get to. I already screwed the DCN board in, and the probe point is on the other side of the board. You know what? You guys are worth showing this to. You are all worth it. So I'm actually going to unscrew this, even though it is about 3:48 in the morning, and I would like to go home, just because I want to show you what this looks like, and I want to give you a bit of an explanation of how this whole thing works. And again, showing you like fixing Apple hardware, this is not where the basic electronics lesson should happen. By the time you get to this level, you really do need to know some basic electronics, or else you're just going to wind up driving yourself crazy, like I am trying to find my T5 screwdriver that I thought I had right in front of me. Here we go. It is right in front of me. It's a good thing I reminded myself of that. So what I'm going to do here is turn this on. That's a T6, not a T5. Okay, once I find the screwdriver, I'm going to turn this thing on. This is why it's good to not work in a mess. The other guy I work with, he is not a mess. He is very clean. He is very organized. I am a mess. I'm a clusterfuck. All of my stuff is always everywhere all the time. It drives the other people who work here out of their goddamn mind. And I don't know. I just kind of find it like a sick little joke that God blessed me with a mind to be able to figure out all this crap without going to college for it, and that he didn't give me the rest of the brain that, you know, the rest of the world has. So where in God's name did I put that screwdriver? It's going to show up as soon as I pause the video. Like as soon as I turn this off to find the screwdriver. Jesus Christ. Let's see. Alright, so this is the part of the video where I give up and I steal it from somebody else who works here, which is something that you should never do. Okay, so it looks like I actually already stole that one of my coworkers' screwdrivers, which means I am in some deep shit tomorrow if I don't find it. So not only have I already lost mine, I've actually already lost my coworker's screwdriver. I mean, technically I bought it, but you know they use it, so it is theirs for all intents and purposes. You don't really give employees tools and then steal them and hope that they find them later. That's inconsiderate. But I lose everything that I touch. It's like I make things disappear. It drives everybody who works here out of their damn mind. I mean, I pick something up. And I go to talk to you for 5 seconds. 5 seconds. That shit is gone. Alright, so let me just get the camera over here so I can get you pointed at the oscilloscope and show you some things that I want to show you. First thing I'm going to do, obviously, is plug this thing in. So let me show you how this circuit works. Even though this is really not the point of the video and not the point of the troubleshooting process, it's just a good thing that I show you how this works so you get a generalized idea. Alright, so I'm going to plug this in. And then I'm going to plug the oscilloscope in so that I can, and I'm going to plug it onto the board so that I can easily show you what I'm talking about. Okay, so where is that probe point? That is right to the next, this IC. Okay, cool. So let's see this on the oscilloscope. So right at that point where I showed you where those transistors are opening, here's what you see. You see that? It's a bunch of pulses. So what it's doing is it's taking that power. So what this is doing here on my oscilloscope, what I've set it to right now, is I've set it so that each one of these squares, which you're barely going to be able to see, each one of the squares is this big. Each one of those squares is 5 volts. You have 5 volts, and this power is actually around 8 or 10 volts. So this is pretty much at the top of this peak. It's about 8 volts. But it's a spike. It's a spike that goes up and then down, up and down, up and down. Now that is controlled by that transistor. So that transistor opening and creating these spikes that you see, so where that transistor is opening and creating those spikes, that is controlled by that chip, that U7400 that I showed you. Now let me show you what the inductor does. So in this circuit you have an inductor, and what the inductor is doing is it is smoothing that out. So an inductor is similar to a capacitor. A capacitor can only pass AC. It cannot pass DC. So a capacitor only passes stuff that does this, that goes up and down, up and down. Now, an inductor, it only passes DC, so it only passes stuff that is flat. So if you want to smooth out your circuit, knowing that ground is where electricity goes to die, that ground is a never land that electricity is always going to go to if you give it a route there, what you can do is you can have an inductor between the spiking crap and your output, which is V-core of the CPU, and then you can have a capacitor going to ground from that output. So you're only going to send the DC, the flat voltage, to the output, and you're only going to send the waving crap to ground, which is the black hole of electricity. So let's measure that on the other side of the board. So I'm going to turn the motherboard over while it's on, and I'm going to measure where that inductor is, and I'm going to show you what the voltage winds up looking like. So the voltage on the other side of this is going to look something like this. So on the input of the inductor, you have this whole steaming clusterfuck right here, but on the output of the inductor, you have this, because the inductor only passes DC. So what the inductor does is it takes all of those spikes of crap and it turns it into a nice flat voltage. So that's the way the circuit works. Now let me show you what was missing from this circuit. So what was missing from this circuit was a capacitor. So this capacitor was completely exploded. Alright, so yeah, so as I said, I want to check and make sure it's recording. Literally at that moment, the battery in my camcorder died. Good thing I checked! So my file size was getting bigger, but I noticed that the audio waveform, so I'm monitoring it over here. As you can see, I got the audio waveform wasn't moving, and I looked at my camcorder, battery was dead. Gotta love it. Alright, so here is the circuit. Let me just zoom in a little bit, since as I said, my TV looks terrible because I'm on 1080p instead of 4K, which is just awful for these schematics, just totally awful. So this is that chip that I was telling you about. And here over here you have PP5E SO CPU IMVP. Do I know what that is? Not a clue. Do I know what IMVP stands for? Not one clue. And do I care? When I have something that looks like this, again, like this, There? No. I mean, come on. I know what the problem is. So it says right here PP5VSO, and as I've said, PP, power, 5V, 5 volts. SO, if you should look up what the SO states of the computer are, by the way, if you plan on doing this. So S states, SO, computer is on. S3, computer is sleeping. S5, computer is off. And there are other S states that I don't even remember off the top of my head. But the important idea here is that when the computer is on, SO, the CPU is getting 5 volts. So this goes here, and this is C7403, which I showed you in that picture. The trace going from the chip to here was destroyed. So there is another place over here where that 5 volts comes to, but that starts over here. That entire trace was just gone. So what I did is I put these two capacitors right next to one another. I scratched away the board a little where this was, and I put a bit of a solder blob there so that the 5 volts would get to it. And then I ran a wire from here to the chip because that trace was damn near dead. And that's what you see over here. So that's what I did with my my wire. Yep, that's that. And it actually does work. So before, when I turned this computer on, we were getting nothing on the screen at all because, again, you can't have something on the screen if the CPU is not running. Again, a lot of people will go, I have no video on the screen. How do I troubleshoot the fact that I have no video? One of the things that you should be looking at, one of the things that a lot of people neglect is my computer even working? Are you going to get video if there's no CPU? You have to think about this because this is important. You can't expect your computer to show you anything on the screen. You can't expect your computer to show you video if your CPU is not turning on. And one of the easiest ways on an Apple-based computer to tell if your CPU is turning on is if it chimes. So even if you don't have video on the screen because your video chip is messed up, which by the way is almost never going to happen on an Air because it doesn't have a discrete video chip, even if your video chip is messed up or anything like that, or your screen is messed up, you should still hear a chime. So if you don't see a chime and there's nothing on the screen, there's a good chance that you don't have CPU vCore, there's a power supply going to the CPU that doesn't work, that you need to look at. So if I were smart right now, I would have unplugged the battery and then gone ahead to do this. The reason I didn't unplug the battery is because I'm being a lazy ass since it's 4 in the morning and I am really just about, I'm here to finish this video so I can go home. I'm not really here to go nuts on this computer. So, but yeah, you need to make sure that you actually have vCore first. So on these boards, do check to see that you have vCore before you start troubleshooting no video. If you start trying to troubleshoot the no video issue and you have no CPU, you really are just wasting your time. So let's plug this in. And again, in these videos, I really do like to show you that the stuff actually works. Because I know that while this channel is small, I know that I'm not going to have a large amount of trolls, but I do plan on this channel growing into the future. And I understand that when it grows, the nature of the internet is such that I'm going to have a lot of trolls, and a lot of them are going to be going, does that even work? Well, yes, it does. I am too bad at video editing to switch in a different motherboard here. So if you watch this channel, if you watch these videos, you know that my video editing skills are just not, they suck. They're garbage. So you are going to notice if I switch another board in here. That board with that nice wire running on it is the board that you're going to see in this computer. You are going to see it boot into an operating system, and you are going to see that it works. You're not going to see that everything's plugged in because I'm leaving that for the guy tomorrow to rebuild. We kind of have like an assembly line thing going here. Like, I will do the board work, he will reassemble the machine. He is not great at board work. I am. I am not good at the basic fundamentals of reassembling things and putting them back together. He is, so it works out very well together that we have this dynamic. So as you can see, I have an Apple on my screen. I didn't screw the motherboard in, so I'm kind of reluctant to lean over too much. Okay, it actually booted very fast, even though it's one of the older machines. Now, it booted... Actually, I got to cover the name over here, because I don't want you people trolling me or looking this guy up in the white pages and stalking him and saying that we saw you on YouTube. But as you can see, I have an Apple wallpaper and an operating system, and yeah, so that definitely looks like there's a CPU working. That looks a lot more like there's a CPU that's working than it did before I put that wire there, which means I'm good. So again, this is pretty much how I use my brain to try to figure out the problem. Sometimes the problem is going to be hidden. Sometimes you are going to have to measure and analyze and learn as you go, and sometimes the problem is just going to punch you in the face because it's going to be a big blob of green corroded shit. And that's that.